Alright, so the homework for lesson 22 is called Partitioning as Distributing Equally. Suppose you were teaching 5th graders about division by a fraction using the following example. 4 gallons of water divided by 2/3 of a foot. And letter A is asking us explain why this partitive model and not the repeated subtraction model is more appropriate for this division problem. And you have to remember that in partitioning problems, we know the number of groups, but we don't know the size of each group. So we have 4 gallons of water, which is our whole, and we have 2/3 of a foot, which represents the number of groups we have. We have less than one group. We have 2/3 of a group. So the answer is, right, we don't have the size of the group. Or the size of one group, I should say. Because in partitioning problems, we're trying to find the size of one group. So we don't have the size of a group. We have the number of groups. So partitioning is better. Write a story problem. So this is in the homework, which I'll upload as well. Ku used 4 gallons of water to water every 2/3 foot of his garden. How much water will he use per foot? Remember, again, in partition problems, we want to know the size of one group. Right? So how much water is he going to use per foot? Or in other words, how much water is he going to use for 1 foot to water 1 foot of his garden at that rate? So it says draw a diagram using a linear model that shows how 4 gallons of water could be equally distributed over 2/3 of a foot. So let's do that. We're going to draw a double number line. It's probably way bigger than I need. And we know that we have 4 gallons. And that 4 gallons represents 2/3 of a foot. Okay, so 4 gallons represents 2/3 of a foot. My number line is it's not off, but it's way too big. Yeah, I'm gonna shrink it some. Sorry about that. Anyways, 1/3 of a foot would obviously be represented with 2 gallons, and this should be our 0 here. Right? 0, 1/3, 2/3. So we know that 2/3 of a foot, or rather 4 gallons of water, is being equally distributed over 2/3 of a foot. So that would mean there's 2 gallons of water for every 1/3 of a foot. And we want to know what 1 foot, right? The size of one group. So 3/3 of a foot, or a whole group, would obviously be 6 gallons. So use the diagram above to determine how much water would be distributed evenly over a foot. 6 gallons. The size of one group represents 6 gallons of water. Alright, the second question. Repeat the steps from question 1, except this time use the following problem. Explain why the partitive model and not the measurement / repeated subtraction model is more appropriate for this division problem. And it's the exact same thing. We have 6/7 of a mile, and this time we have 3/5 of a group. So we are not given the size of one group. We're given the number of groups. Here's a story problem. Ku is drawing a scaled diagram in which 6/7 of a mile is represented by 3/5 of an inch. what distance would 1 inch represent in his model? So we'll draw a diagram using a linear model that shows how 6/7 of a mile could be equally distributed or spread over 3/5 of an inch. I'm going to try to do a little bit better this time. So let's say this is 3/5 of an inch, and let's say that this is 6/7 of a mile. So if this is 6/7 of a mile and this is 3/5 of an inch, then what do we know about how much 2/5 of an inch would represent and how much 1/5 of an inch would represent? Right? If we take those 6/7 of a mile and we break that up into 3 equal parts, then there must be 2/7 of a mile in each one. So using that, we can find out the size of one group, right? So 2/7 of a mile represents 1/5 inches. So then 4/5 of an inch, right, would be another 2/7 of a mile. That would be 8/7. And last but not least, one group, or 5/5, would be represented by 10/7 of a mile, or 1 3/7 miles is our answer. How many miles will be distributed evenly over 1 inch? 10/7 miles, or 1 3/7. How do you determine how many miles are in 1/5 of an inch? We knew that 6/7 miles represented 3/5 inches, so we took 6/7 and we split it into 3 equal parts. Right? 2/7, 2/7, and 2/7. And then how did we determine how many miles were in 1 inch? All we had to do was extend the number line. Why, or how were we able to extend the number line? We knew that 1/5 of an inch, we knew that 1/5 of an inch was represented by 2/7 of a mile. So we could easily extend our number line, right, 2 more places and add 4/7 of a mile. So 6/7 plus 4/7, that's 10/7. I think that's it for the homework. Let me know if you have any questions.